All right, hi there. So today we have ourselves an A1425. This is going to be a MacBook Pro made between 2012 to 2013. It's a 13-inch, early 2013 specifically. And this one's in here because it's just not showing any light on the backlight. Now, one of my technicians has already gone ahead and replaced the EDP cable that connects the backlight on the logic board to the actual, the display connection from the logic board to the actual LCD itself. And after doing that, the backlight's still not working. So we did find that there was a little bit of corrosion around the EDP cable itself. So this looks like at some point this has been liquid damage. So let's see exactly what it will take to get this one working. So I'm going to go ahead and remove the battery, and then I'll replicate the issue real quick. Also unplug the solid state so we don't end up damaging any customer data in the process. This one's a very strange model. We really don't get this one in too often, the A1425. They only made this model for pretty much a year and a half. It was the late 2012, or it was the very first Retina model, to early 2013, until they switched over to the more common A1502s, the late 2013 to 2015 MacBook Pro Retinas that we see today. Okay, so it's weird in the sense that it doesn't actually have like a traditional cable that plugs in. It just has almost like a contact that is screwed down, so just tension. You have your positive and your negatives right here. I would assume this one is going to be positive. This is our ground right here. And we have this little inner connector. So we'll just set that to the side. And then the solid state is in the strangest location. It's actually underneath the trackpad on this model. So that clip just pops right out. You just kind of grab this, push it in, pops right out. So let's set their information to the side and just replicate that this does indeed have an issue with the backlight. So we'll plug in our charger and hit our power supply. So we can hear it's chiming, but we don't see anything at all on the screen. So how we're able to determine that this is an issue with the backlight itself is if you can clean the area up right here in the center where there's no smudges, you can then get a flashlight. And in this case, since we removed the solid state, we're going to see a question mark. Right there, you see that? So the display cable is actually working, but the backlight, which illuminates the LCD itself, is not working. So let's see if we can fix that. So just to show you where we found the corrosion, right here on this cable, the EDP cable, you can see that there's a little bit of corrosion. Alright, so I'm messing around with color filters on OBS, so the gamma is turned up a little high. Everything looks a little green. I'm going to change this real quick because it looks a little odd in my opinion. Bear with me for one moment. Let's see, this is going to be under filters. That's a little closer to what everything looks like. And the gamma, let's bring that down a little bit. That's closer to what I see. Okay, back into the video. So you can see without even zooming in further, right here, this is going to be our PPV LED backlight. This is what actually sends power to the LCD itself to illuminate. It's just, in fact, actually, look, there's supposed to be a pin right here. That pin is completely No, there's not supposed to be a pin there. But there is a piece of metal that is lodged in there. That is bad. So I'm going to go ahead and just pull the board out since we see a little bit of corrosion to see if there is any other corrosion on the underside of the main logic board. So in a couple of my streams, just for fun, I played smooth jazz, some royalty-free smooth jazz. But the problem is I did it on YouTube, so I guess someone had filed a copyright claim on it. So because of that, unfortunately, I don't have any fun smooth jazz to play during this montage. Well, let's just start pulling things out. It's been a while since I've actually done a board repair on this specific model logic board too. I do like the idea that they have two fans. Unlike the A1425s, they're a great design and they have a much larger fan, which is probably more efficient in the long run. But I do like the idea of having two fans. I think these were known though for having bad, not necessarily GPU, because this one doesn't have a dedicated graphics card. I know the 15-inch, there was actually a recall on the 2012 and the 2013, but that was more of a GMUX issue rather than a GPU issue. The actual power supply for the graphics, the MUX chip, was known for just not having the right amount of solder. So that is a common thing we see with these models, or with the earlier 15-inch Retina models. But this model, the only thing that I think we've done with it has been like SSD upgrades. There was one recently, we actually had to replace the logic board because the RAM, which as you can see right here, like all Retina models, is actually soldered on. So we ended up replacing the board. It was a computer that we ended up selling the customer anyway, so we just did it under warranty for them. But these don't really come in for too much. I also find this one is very weird to screw map. There's a lot of unnecessary screws in this model. And the battery is starting to swell too, so we did get approval to replace the battery as well. Alright, so it looks like up here in the top left we have one Phillips screw. What else do we need to remove here? We got the fans, MagSafe. Need to unplug our daughter board. Looks like a speaker's still connected. Our fan is still connected. Other than that, that looks like that's all the screws. And our backlight cable's still connected. Ooh, yeah. Did you hear that crunch? So there's something sticky inside of here. Okay, so this is the model that you actually want to leave the fan plugged into the board itself to remove easier. Oh, what's this? This looks like this might be the microphone. Yep. Okay, nothing too obvious on this side. Okay, to make matters easier for me, I'm actually just going to put that screw back in for that fan. And we can set the rest of the computer away in our side drawers over here. I'll work on that in a second. And just to make sure we don't get things lost, let's keep all this together. Okay, so let's take a look underneath, because I did hear a little bit of crunchiness whenever we were pulling out the board just now. Macs usually aren't crunchy. Pardon me for a moment. It's after hours right now and I'm a little parched. So I get okay. Let's examine our board here. So our EDP cable is going to plug in right here. And let's get this all in focus. Okay, so we know this is bad because of the corrosion burnt up right there. But what about on the underside? Is there anything else over here? And get this in focus as well. Everything for the most part looks okay. Yeah, just a lot of dust. But I don't see anything else. So it looks like our only issue we have, hopefully our only issue, is going to be our EDP connection. Pretty sure this one's EDP. I don't think this is still LVDS. And let's just use our multimeter here with continuity mode to see if there is a short on our PBV LED backlight. There's not. Okay. There kind of is. We have a resistance of 76, and it's probably just because the plastic is melted right here. So what I'm assuming is that there was a little bit of liquid that got on the logic board, and specifically where the cable plugs into the motherboard, and that essentially had just burned away a hole into our EDP connection. We went ahead and replaced the cable anyways because the cable looked like a couple of the pins were bent. Burned up. So this may just be our only issue. Let's go ahead and replace this and see if that resolves our issue. So it has been a little minute since I've done board repair, but streamed my board repair since we've been so busy, but I finally invested into an actual adult soldering fume station. The last one we had, it was also a Hako. I think it was only like $90. This one, the A1425, it was a lot more than I'd like to admit, but it was about $800. But my wife made a very valid point. You can't really put a price on preventing cancer. What is it? It's like an ounce of prevention versus a pound of cure. So finally just bit the bullet and got an adult fume station. Alright, I'm going to remove this fan just so that we do have a little bit more wiggle room. And the question is, can we even remove the fan with the heatsink still attached? I think this model we can't, not without bending it. Okay. I actually don't feel comfortable with that, so I will leave the fan in its place. We'll end up giving this an ultrasonic cleaning anyway, so then I'll remove the heatsink at the time. But we can remove our MagSafe board. Alright, so let's load this area up with some flux. And to help melt this with our rework station, I'm gonna go ahead and just put a good bit of new solder over our pins here. That way these will melt at a lower temperature. And now that we've applied enough solder, let's go ahead and start removing this. Yeah, I don't like messing around with the color. That filter looks like it made everything look a little washed out, so I'm gonna play around and with the settings a little bit more and change that back. Alright, let's see if we still have an impedance of 73. Okay, we have an infinite resistance. So the EDB cable was the entire reason why we had a minor short. It wasn't a full short, but it was enough that if we tried hooking up another cable to the LCD, it was just going to end up melting away. So I'm just wicking this stuff right up. That all looks good to me. And let's clean the residue off. And real fast, let me actually go ahead and change the filter on here. I'm not too happy with this, but it's a decent camera for what we paid. Let's see if removing that. Okay, that changed things a little bit. It's good for educational purposes. It's not the best camera. So now with our new EDP connection right in its place, I'm going to go ahead and put the grounds on first, just to hold everything together. And as you can see, my hand shook a little bit, so everything moved over. And let's move it over just a little bit more. Okay, so now that I've touched those two grounds up, let's focus on the major grounds on the outside. Wow, the quality of this video. Like through my camera, or through my view hole, it is much clearer. Alright, now let's go ahead and put some new solder on our joints. I'm gonna touch this up with my normal soldering iron, and then any spots that are touching each other, I will go in with my micro pencil and fix. But for the most part, I can get by with just using the normal soldering iron. I think we got it. Yep. We got every single leg on there. That was probably the fastest one I've done. Cool. So this one should be good to go. And just to make sure there's no weird fluke with our impedance here. Yeah, we still have an infinite resistance. Awesome. So here's the old one, and we can just kind of say goodbye to that. So let's reassemble this one and see if we fixed it. I'm not going to close it up all the way because we will give it an ultrasonic cleaning, because if there was a little bit of corrosion right there on the board, there might be something that I can't see that will cause more issues in the future. Everything is tightly packed in this one, so we need to make sure that all of our cables are exposed. So our trackpad cable is hiding right here. Our keyboard is hiding as well. Okay. And we're just going to loosely put everything in. We won't worry about screwing too much down. just to see if we fixed it, because with that much of a short, we might still have a bad backlight fuse. And actually, as I'm looking at the daughter board, there's a little bit of corrosion over here too. We may just end up replacing the daughter board to make things easy for us. Okay. Now let's plug in our newly replaced EDP cable. All right, and let's see if that fixed it. It's really hard to tell. I want to say it did turn on, but I didn't grab the option button in time, so it's not showing us the option boot. So let's see if it shows us the question mark with the folder here in a second. Our fan is running at very high temperatures, which means something's not plugged in all the way for like a temperature sensor. In this case, it's going to be the trackpad. Okay, so nothing yet. Let's look at our... Yep. With our flashlight, backlight is still not working. Okay. So, looks like we do have a further issue down the line. With this cable plugged in, I'm going to check and see if we have a short. And then we're going to pull out the schematics and kind of see where the backlight circuit functions on this model. Okay, so what does this pin have as far as backlight goes? It has infinite resistance, so we're no longer shorted. So now at this point, let's pull out our... You know what? I probably should have done a PRAM reset as well. But I feel like we would have still gotten backlight. So I think at this point, we're just going to have to pull out the schematic. Let's also go ahead and plug the trackpad in its place. Just so when we try turning it back on, we can actually hit the option key. Okay. Let's see. Which logic board is this one? Okay, I don't necessarily see a board number on top of the board. Not one that is obvious, at least. I do see a fuse right here. So at this point, I'm just going to use a very handy site that Chris at Shiny Computers has made that has all this information about the board numbers. In case you ever need to get to yourself, it is Logi for logic board, not Loogie, .wiki, and there's all sorts of great information on here that a whole bunch of technicians have collaborated together to make, but there should be one on here that says right here, board number by A number, and so we know that this one's an A1425, so it shows right here the board number is either an 820-3462 or 820-3191. Now, from my understanding, these are pretty much the exact same board. So let's take a look at the 3190, because I feel like this is a 2013. Just going to go off of my gut here. Let's see if we even have this one. So what do we say, 3190? 3190. So we're just going to open up Flex Board View, created by Paul Daniels. Without this software, we would not be able to fix devices like we do. What do we say, 3190? We do have board view. So let's take a look here at J9000. All right, J9000. We can see right here, pin 1, which was the is our PPV out SO LCD backlight. Okay, and let's check and see where further up the chain this goes. Aha. So we have some capacitors on this side, which we know are not shorted. And over here, some more capacitors, a diode, which means we should also have a backlight driver somewhere over here. Such an odd place. Let's actually look at the schematic to make sure that we are getting power out. So where else is PPV out SO LCD backlight located? According to the schematic, nowhere. That's not right. Alright, so right here, and nowhere else. Is it all over here? This isn't going to show us where the rest of the circuit is? Oh. Because we can see that we have a diode right here. So let's see, where is this D9701 coming from? Okay, this is going to be our backlight circuit right here. I don't know why it wouldn't show. Is it because it's an underscore? It is. So this is PPV out underscore SO LCD backlight. That's why the schematic wasn't able to find it. Make sure that it's turn on. And let's see where this is located. This is probably underneath the board. It is. It's not horrible, but it's just not ideal, because as you see, everything is already tightly packed here. So this looks like any other backlight circuit in other units. So, all right, well, we thought that we were getting lucky with just replacing the EDP cable. So there looks like there might be a further issue. Actually, hold on. Let's see where this fuse is at for PP-Bus LCD backlight. F9700, right next to our keyboard connector, the part that I thought looked just like a fuse. Interesting spot of all places. Backlight's over here. Backlight fuse is right here. Okay, let's make sure that we have continuity. And hopefully, we're going to touch this, and there's no continuity. No beep. No beep. Fantastic. We might actually be able to solve this one real quick. All right, and just to make sure that there's still no short, let's touch both sides of the fuse. Awesome. So it looks like we blew our backlight in the process of, well, we didn't blow it. I'm sorry. Let me take that back. When the liquid had went into the EDP cable, because the computer was thirsty, it destroyed the EDP cable, the EDP port, and in the process, the fuse. So the fuse did its job. Hopefully we'll replace this, and the rest of the unit will turn on. Let's find out. So what we need is replacement fuse. And I have one left. until we're able to place an order for some more. Cool. So we're going to switch over to our hot tweezers. And beforehand, let's take a quick tea break. Awesome. Such an odd spot to put the backlight connection. The backlight fuse. Sorry. And it is really on there. Since the wire is split, it's kind of hard to heat up both sides at the same time. But here it goes. Alright, sweet. And I'm just going to wick up this area a little bit. I'm going to wick up this area with a normal soldering iron. And wait for the beep. There we are. Okay, let's try this with the new fuse. And that side looks ugly, but it's on there. No, I'm just kidding. We're going to fix this up a little bit. Okay, it's on there at an angle, but it is going to work. So now what we want to hear when we put our multimeter up to it, it's going to beep. It's gross, it works. All right. Let's turn this on. This time let's option boot. Our keyboard is plugged in, right? It is not. Okay, so now we got to find out if it's going to show the question mark. And I can tell that the backlight is already on. So that was a successful backlight repair. There's our question mark. And We're going to do an ultrasonic cleaning with a quality control test afterwards, but that's how you replace or fix a backlight circuit on a A1425. Now, this is not the only way to fix the backlight circuit on this specific MacBook Pro. If you have one that's not turning on, don't want you to think, oh, just replace the EDP cable, the J9000, or the fuse, and they'll fix it. The fuse is going to help, but fuses will only ever pop if there's ever too much current drawn or too much power going through it. So if there's too much power, there's probably a short or a partial short further on down the line. So if you replace the fuse, chances are it's going to blow again, and then you're just going to go through the cycle of replacing fuse after fuse. So just to show you the complexity of this backlight circuit here, so we have our PP bus comes in through here, and PP bus in this case, is going to be a 12.6 line. Now, PP bus will go through a series of MOSFETs here that basically meet certain requirements in order for it to send PP bus LCD backlight power, or switch LCD backlight power. PP bus, let's see, where eventually does that go to? This is definitely needed to turn on. Let's find out where else in the circuit it goes. Okay, well, PP bus switch LCD power, LCD backlight power will eventually turn into PP bus SO LCD backlight power. And that is going to be, goes through a series of power right here. So we have a coil. The coil will then turn into PP bus LCD backlight power switch, which is the same line we saw. No, it's not. Never mind, because this one's an SO. Then we have a MOSFET right here, which is part of our driver, our U9701 driver, which has our backlight switch. And so whenever this is working like it should, it will then allow power through to our diode, which will then go through a voltage drop right here for feedback to let this circuit right here on U9701 know that everything's working like it should. And it continues power out, which can be anywhere from 8 volts to all the way up to 55 volts. That is a lot of voltage in the computer. So that's why whenever there is a little bit of liquid on your EDP cable, it will burn. It's a lot of power. So we got very fortunate here, because when we looked at our board underneath the microscope, we could see that J9000, this is huge compared to the rest of the computer, was corroded on pin 1 specifically, which is our backlight. We then were able to figure out that our fuse was bad. The F9700. Now, this I know from experience, but if you were new and didn't know where the fuse or what the fuse was responsible for, this is the end of the circuit. So what you want to do is measure the front of the circuit and the end of the circuit and kind of meet in the middle and see where the issue is. So we were not getting our anywhere from 8 to 55 volts on our PP Vout SO LCD backlight. So we knew the end of the circuit was bad. So at this point we knew, let's check the front of the circuit. Well, the very beginning of the circuit is PP bus going from our state 0 LCD backlight. So we would measure, if we took our multimeter right here, we'd have 12.6 volts. But if we checked on the other side of the fuse, the F stands for the fuse, there'd be nothing. So that's another way of figuring out that the fuse was bad. Now, if the fuse was good, then we would check everything else in between to see if PP bus switch LCD backlight power is on. If that's good, we want to make sure our driver, which is our backlight driver, this is the chip responsible for controlling backlight, we want to make sure that it's getting power from voltage in, VLDO, VDDIO, and if all that is good, we will then look further on the line. Is the diode working? Is this MOSFET right here, is all this working? Are the resistors properly dropping the right voltage drop like it should? And you just troubleshoot where in between everything is. So I don't want anyone to use this video thinking, hey, replace fuse 9700 because Esteban told me to. False. You need to use your brain when it comes to board repair. And then when I do streams, I really just like to show people everything that a live brain thinking, or can't think right now. Trying to show that you actually need to think when doing these type of repairs. So that's my tangent for it. I hope this has been fun, informative. I'm going to keep trying to do more videos. Maybe instead of doing more live streams, I'll actually do a little bit more professional, like cut screens and things like that. But until then, thank you for joining me for this 45-minute stream. You guys enjoy the rest of your evening, and I'll see you in the next one.